right, we've got 4-3, day 2, our last two functions. Day 2. They are tangent and cotangent. And I just want to show you real quick the graph of cotangent. We're going to set that window up from 0 to 2 pi again. Clear that out. And cotangent, I want 1 divided by tangent. That'll give me cotangent. And in the window, I want to go from 0 to 2 pi. I think it's still there from last time. And then graph. Okay. So, the newer operating systems won't have that vertical bar in the middle of the screen there. It's a vertical asymptote. I don't know why the newer operating system doesn't put that in, but the old ones do. Try that. The y, 1 divided by tangent. So this is cotangent you're seeing. Okay, how many cycles of cotangent are you seeing? 2. And that went from 0 to 2 pi. So what do you think the normal period length is? Pi. So that's a change from the other 4. The other 4, the normal period length is 2 pi. Tangent and cotangent have a normal period length of just pi. Then they start repeating themselves.
The reason we did cotangent before tangent?
Yes, because cotangent actually starts nicely at the, has that vertical asymptote at the y-axis. Tangent does not. Tangent's a goofball for us. It screws up the whole pattern that we've had before, so that's why I didn't do tangent.
Were you tangent at all?
So oh yeah, I'll tell you the little differences in it. But cotangent starts with an asymptote, ends with an asymptote, and then there's 3 spots in the middle. So we're going to have 5 points again, just like before, and I'll talk about them now. So let's do cotangent first, because I think it's the easier of the two. So we've got y equals cotangent x. Okay, the important thing to remember here is that the period was just pi, not 2 pi. So on the table, we're still going to have 5 key values. One, 2, 3, 4, 5. So it's going from 0 to pi. So that's our first change. So that period length is pi. And you just average to get the middle. So the critical value in the middle is going to be at pi over 2, pi over 4, and 3 pi over 4. And if you look, what's happening at the 0 is a vertical asymptote. So it starts with a vertical asymptote, so the cotangent of 0, and I could have you look on your circle sheet and look it up. The cotangent of 0 is going to be undefined, and then the cotangent at pi is going to be undefined. And the graph, I'll show you the graph real quick. If that's pi here.
Middle value,
Nope. Take a look. The graph looks like this. Here's my pi over 2. Here's my pi over 4, and here's my... The graph is just crossing right through. It has a 0 at pi over 2. The graph looks like this. It scoops down like this. Then what's happening here is it's changing its concavity. Like this line that I drew here, we call that concave up because it's kind of like a bowl shape. Now take a look at what's happening after this spot. That concavity switches and it's concave down. So that critical point in the middle is where it's switching its concavity. You know what I mean by concavity? Can you see it? This is concave up, like the cereal bowl up, and then this is concave down, like the cereal bowl down. Okay, the critical points here and here match our old amplitude number. Where does amplitude come from on the other functions? The multiplier out here. That's true here. That amplitude number comes into play right there. So the pattern for cotangent is starts and ends with an asymptote. The first one, we can call it a max, but it's not a max, just that it tells us to go above the axis. So think max. This middle one is on our axis, so if we have vertical shift. And then min. We call it a min, but it's not truly a min. It just gives us the direction that the graph is going into. So it's max, ax, min. Okay? So we've got our, oh, I lost it. Remember I said they were doing the wrong song with the, oh, you guys didn't see it. They were showing, I was showing some YouTube things that were very bad. They were doing the graph with different songs and stuff on YouTube for extra credit, old math classes. But their tangent and cotangent, to me, this, I call this the staying alive graph. Because it starts high, comes down. Should have been playing staying alive, so that starts high, comes down. Can you hear it? Oh. Hey, what do we do tangent? Both of them. At least you laughed. Just so you know, my daughter was totally embarrassed the first time I did that. Yeah, that was Jordan though. Paige is coming yet. She'll crawl under her desk next year about this time. So okay, so we've got our pattern, and then we're going to be doing the 4 things with vertical shift, phase shift, all that good stuff. So our value at pi over 4, this would have been a 1, a 0, and a -1, and we just know that max just means it's going to keep going up, and the min is going to keep going down. Okay. Cotangent, until we start shifting things, it's going to start at the phase, and the ending value is going to be phase plus period. So that doesn't change. Tangent, on the other hand, is different, because tangent doesn't start on that y-axis. And I can show you real quick. You go back to y equals, and you type in just tangent. What you're seeing here, on that x-axis, you're catching the upper half of a tangent, then an asymptote, then a full one, and then a bottom half. So it doesn't start nicely on the y-axis like all the other graphs did. So that's why tangent's goofy. Of course, we couldn't have all 6 things be nice and neat. So tangent,
Wait, what do you mean it doesn't start on the y-axis?
I'll show you. The period is still pi. There are 2 full cycles of tangent there, just that the one's broken up into halves, the top half and the bottom half. So the period is pi. But if I wanted to see that first cycle of tangent, let's see. This is my, pi is right. That's going to be at pi over 2. It hits the origin and does this little number. That's half of tangent. What we're missing is the other half that's down back here, which is at negative pi over 2. So the first cycle of tangent technically starts at negative pi over 2. That's what I mean. It's not starting itself at the y-axis like all 5 other graphs do. So what that does for us is it screws up our starting x value. So what we're going to do one, 2, 3, 4, 5. This normal tangent with no changes to the amplitude, the period, the vert, the phase. Negative pi over 2 is our start. Normally we start everything at the phase. This is not the phase. Okay? Finishes at pi over 2. That puts 0 in the middle. Negative pi over 4. Positive pi over 4. I'll tell you where to get that starting x value from in a minute. But just like cotangent, tangent is centered between two asymptotes. So the first one and last one are always undefined on tangent and cotangent. Never going to be anything different than that. Your middle value is always going to be your axis value, just like it was for cotangent. So what is different? At negative pi over 4, I'm down, and then at positive pi over 4, I'm up. So the pattern is min, ax, max. So it's the left-handed staying left. Staying left. They can't see me though, all they see is here. They're wishing they were here though. Wishing they were here. What is she doing today? What's that?
Why is there an ax?
Oh, it was 0.
Okay.
0. Okay, so we've got our pattern. No!
Why?
Go away, wait till later. Okay, the starting x value. This has a little formula. So for tangent, the starting x value has a little formula. To get that first x value, where it would normally be at negative pi over 2, unless we have some phase shift. It's going to be negative pi over 2, divide by the b, and then add on the phase shift. You've got to calculate the starting x value. It's the only graph that's going to give us fifth. So all other 5 graphs start at phase. Tangent is the only one that doesn't start at the phase. If you can remember that, it's got a little formula you're going to have to write on your note card. And then the ending value, you just take your x1, whatever you calculate, and add on a period. And then it's average to get the middle. So we are going to do all 4 things. C plus A, we've got tangent and cotangent. B times x minus d.
Looks like a new...
It's just all the 4s. We're just going to describe all 4 things again. Okay, the A is in the amplitude spot, but again, these graphs go down forever and up forever. Amp is a measurable distance, so what are we going to say for amplitude? NA. But we are going to use the A number for our max and min values, even those aren't maxes and mins, they're just kind of giving us the direction that's going up. A will give us max and mins in our table. Period. The other 4 functions have a normal period length of 2 pi divided by a b, if there's a b. For these ones, we just got to remember it's not 2 pi, it's pi divided by b. So that's a change from our other 4. Vertical shift is still going to be the c. That's going to give us our axis values. And phase is still the opposite of the d that's in here, the d. And I use the lowercase d here, but I do mean whatever the phase is, that's what you're going to add on here. And whatever the capital B